అందరికీ నమస్కారములు. గురుభ్యో నమః. శ్రీ మహాగణాధిపతయే నమః. సరస్వత్యే నమః. Today is another good day for all of us. Today is the last day of Vedic mathematics. We have completed important topics, very important topics in this course. Vedas, Vedangas, Upanishads, Darshanas, Dharmashastras, Panchangam. And now we are on Vedic mathematics. This course is being organized and run by Veda Samskruti Samiti in consultation with Vishwa Vidyapith. 1 month is completed, second month is running now. In the second month, the first topic is Vedic mathematics. We are going to have an exam during end of this week on all topics which are covered during the first month of the course. That is on Saturday morning from 6:30 to 8. Now, let us start the session with reciting Vande Mataram by Chala Chittibabu Garu and then Prarthana by Surya Prakash Garu. Chala Chittibabu Garu, please.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malaya Sitalam, Sasya Syamalam Mataram, Vande Mataram, Subrajyosna Pulakitayamini, Pullakusumita Drumadala Sobhini, Suhasini, Sumadhura Bhashini, Sukhadam Varadam Mataram, Vande Mataram, Vande Mataram.
Vande Mataram. ధన్యవాదములండి చల్లా చిట్టిబాబు గారు. Now let us request Surya Prakash Garu to chant Prarthana, please.
Yes, sir. Namaste, sir. Sarvebhyah namaskaraha. First, let us observe 1 minute dhyanam. Don't let let go your manas somewhere else. Let it be in the class for another 1.5 hours. Let us chant Omkaram 3 times. गणानां त्वा गणपतिं हवामहे कविं कवीनामुपवस्रवसमं ज्येष्ठराजं ब्रह्मणां ब्रह्मणस्पद आनशृण्वन्नोतिभिः सीदसादनम् ॐ श्रीमहागणाधिपतये नमः। ॐ प्रणो देवी सरस्वती वाजेभिर्वाजिनीवती दीनामवित्र्यवतु। ॐ श्रीमहासरस्वत्यै नमः। ॐ मातृदेवो भव, ॐ पितृदेवो भव, ॐ अतिथिदेवो भव, ॐ आचार्यदेवो भव, ॐ अतिथिदेवो भव। गुरुरेव गतिः गुरुमेव भजे, गुरुणैव सहास्मि नमो गुरवे। न गुरो परमं शिशुरस्मि गुरोः, मतिरस्ति गुरौ मम पाहि गुरो। ज्ञानानन्दमयं देवं निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे। श्रुतिस्मृतिपुराणानामालयं करुणालयं नमामि भगवत्पाद शङ्करं लोकशङ्करं। शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः। ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः। ॐ सहनाववतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः। नमस्कारः सर्वेभ्यः नमस्कारः। धन्यवादः सर।
ధన్యవాదములండి సూర్యప్రకాష్ గారు.
ధన్యవాదాలు సార్.
Okay, now let us request Gautham ji to start the webinar, please.
सर्वेभ्यो नमो नमो, सभी को नमस्कार। So we did this algebraic explanation for sorry, square root of the this procedure, square root procedure, and then we did also a bigger one, maybe some part here actually it is actually 1 2 3 4 5 6 7 8 digit number, and its square root comes into 4 digits. We have done these things. This also can be seen later. So there is one step somewhere actually up to this is fine, but I hurriedly made it shortcut somewhere in the, so you have to correct it later. But nevertheless, as I told, the first few steps are if it is already perfect square, there is no decimal point. So first 4 steps actually gives the 4 numbers, 4 digits of the square root. After that, it is to verify that there is no decimal point. After that, some process is there to verify that there is no decimal point. So today we start with a different topic. Please ignore this bottom line 0, 1, 2, 3, and 4, those things. Those things are actually small subscripts, superscripts, by which these powers are taken. Powers can be taken from here. Now, remainder theorem. First of all, this remainder theorem. The remainder theorem says that in this format, normally you will not. I expect that many persons who do not have algebraic background may not understand. The remainder theorem says that when a polynomial px, it is actually maybe x square plus 5x plus 6, something like that. is divided by a linear polynomial, say x minus a, that means suppose x minus 3, then the remainder is equal to p of a. P of a. That means that suppose there is some ax square plus bx plus c, you replace all the x by a, and suppose it is 2x square plus 5x plus 3, and then you replace all the instead of this x by a, and then you calculate a may be another number, say 2 or 3, whatever it is, and then you can find out the number, what is 0 or not. Then it enables us to calculate remainder without actually dividing. And PA is going to 0. That means when after putting that substituting x with a, if we get 0, that means it is a root of the polynomial. That means there is no remainder, so obviously it will be a factor. So then it will be a root of the polynomial, this px is equal to 0, and also x minus a becomes a factor of px. Remainder theorem helps to factorize a polynomial px. Actually, algebraic applications are more. So example is given here. Find the remainder when polynomial px 3x square, 3x to the power 5 minus x to the power 4 plus x cube minus 4x square plus 2 is divided by qx, that means x minus 1. Solution. So what we'll do, as you told, I will substitute all these all the x by 1 here. X minus 1 is equal to 0 signifies x is equal to 1. So we have to substitute as x is equal to 1. So we'll substitute zeros of qx, which is actually x is equal to 1 in the remainder to find the remainder r. X is equal to 1. So what to do? R, so remainder is equal to p of 1. That means instead of x, we substitute 1 here. So 3 into 1 to the power 5 minus 1 to the power 4 plus 1 cube and 4 1 square plus 2, 3 minus 1 minus 3, this one, if we calculate, the answer is 1. So that means if this polynomial is divided by x minus 1, the remainder will be 1. It is understood? It is understood by persons who actually are doing algebra.
All are unmuted. All are unmuted. You can respond. If you have any doubts, you can always.
Got it, sir.
Yes, sir.
Understood.
Got it. Yes, sir.
Now, there may be various applications. There may be various applications, but the application may be, for example, good application can be, say, for example, I was doing this thing. Suppose there is a number. $345. I want to see that what is the remainder when this is divided by 12. What is the remainder? I'm not interested in the, then I have to go for the division. Easily I can find out that what is the result of this, I mean the remainder of the division is R. My handwriting doesn't come good here. So what do we do? So here it is, this 12, I express in this form. Actually, it is 1 into 10 plus 2. As I told, I can replace all this 10 by x. So it is actually x plus 2. X plus 2. And 345. So 3 into 100, 3 into 10 square plus 4 into 10 plus 5. So I replace it, write it here, 3x square plus 4x. For any x, it will work. So therefore, with x is equal to 10, also it should work. Now it says that the x plus 2 is equal to 0. This is this is the zeros of that. I have to do x is equal to minus 2. X is equal to minus 2. So what do we do? To check the remainder, I have to do 3 into minus 2 square. Please, anybody else tell? Plus 4 into all the x I am replacing by minus 2. Here, please.
Minus 2
Minus 2.
4 into minus 2
plus 5.
plus 5. So results come into what?
12
This is 12 plus 12
minus 8
minus 8
Plus 5.
Minus
5.
8 plus
9.
9.
is equal to 9.
Yeah.
9 is equal to 9. Now, how should I check it? Now, I very quickly here say, suppose I will erase this part, make it slightly 345. I've written already here. So I switch on my eraser. Erase this one, erase this one. Made it slightly get it here. Now 345. 345. What it do? Whatever the method I do, for example. So had it been divided by 10, it will by this my quotient and remainder. Now 12 I am dividing with minus 2. So 3. Can anybody remember quickly? 3. So what to put where? 3 minus 2 minus 6. Isn't it? And then next step, anybody? Anybody next step? This division? I'm sorry, I'll switch on. Anybody remembers? So 4 minus 6 is 4 minus 6 is
Minus
4
2.
minus 2. Minus 2 into minus 2. It is plus 4. We put in the remainder format. You remember, we have crossed Paravarta, so that doesn't mean that you have to forget Paravarta method, isn't it? Division method. So my quotient becomes 28 and remainder 9. See whether it matches with this one. So this for this procedure you have to do so many steps, but for this one is simply substituted minus 2 in case of all this all the digits, and directly arrived into the remainder. You just compare, both are fine. Here you are getting quotient and remainder both. You understand? You remember this Paravarti method of division? Now you remember, no, after doing this?
Yeah, students have to respond whether do you remember or not.
You remember this Paravarti method of division?
See,
Now-
everybody's unmuted, so you talk. There's a question being asked. Are you again muted or what?
Yeah, maybe.
Okay, go ahead, sir. Go ahead.
Now I will see. Now this is the mystery of that 11. So suppose I am giving a big number. 7, 4, 3, 5. And I have to see what is the remainder when this number is divided by 11. 11. What should I do? So 11 means 1x plus 1 is equal to 0. So here x is equal to minus 1. So I have to do minus 1 to the power, this is 0, 1, 2, 3, 4. So this becomes 7 plus, this becomes odd cube, so it is minus 4. This becomes positive 1 square, minus 1 square. This becomes minus 1 only, minus 2 and 9. So for divisibility with 11, we did like that, no?
The answer is 7.
So it is 7, 7 minus 4. 3, 3 plus 3, 6 minus 2 is 4, 13. 13 that means ultimately it becomes, again, by 11, it becomes 2. So if this is divided by 11, this will give 2. So likewise, this remainder theorem can be used. More examples, somebody?
How did you write this 13 is to 2? Please.
Huh?
In the previous one, the ultimate, when you got the answer as 13, then you said it is 2.
Oh, 13 by 11 is 2. 13 cannot
Achha.
be remainder third.
Okay. 13 minus 11.
Yeah.
Okay.
Now, I insert one more slide better actually. Now, actually, that way it's actually, you can tell me that suppose given a number, sometimes what happens, we have to do some, suppose we are giving, want to take the remainder of a division by 18. 18, then what should we do? How can we express it? First, let us see, not 18, 8, simpler one. 8. 8. So, a remainder with 8. So, what should we do? Can anybody tell? How can I express into simpler form to be fit in the remainder theorem?
-2.
It is 10 minus 2, isn't it?
Minus-
We express it in this format, vinculum. So it is actually 10 minus 2. Therefore, it is, I will say it, x minus 2. So, to get this to do process in the remainder theorem, we have to substitute x with 2. X is equal to 2. Now let us see, you tell me any number. You tell me number so that I can see whether it is, what is the remainder when it is divided by 8.
27846.
27846. Now it should be, this should be 0, 1, power of x, 1, 2, 3, and 4. 10,000, 20,000. So 2 into
10 to the power of 4.
2 to the power 4 plus, this also becomes big, of course. U plus 8 into 2 square plus 4 into 2 plus 6. So in case of divisibility with 9, do we not add all the digits? So you can you find a similarity of with this? Suppose consider it to be 9, then it will be 1 and minus 1. So x is equal to 1. Instead of 2, it will be x is equal to 1. Then there will be no 2 to the power, everything will be 1 to the power. So it just straight away we add for divisibility with or remainder with 9, we do 2 plus 7 plus 8 plus 4 plus. So we can see transparently here. Only thing is that if it is 8, we are doing it powers of 2. It will be bigger, of course. You tell me 2 to the 4 is 16, 32 plus 7 into 8, 56. Someone might please calculate it in the calculator. This is 32. Plus 8 plus 6.
134.
134. So this becomes my remainder, but 134 is very big remainder for that. So we again see that what is the remainder. So with 134, we again do 1 into 2 square plus 3 into 2 plus 4. So in case of 9, suppose had we gotten something like this, again we just added this. So instead of that, in case of 2, we just it becomes it's 4 plus 6 plus 4.
12.
4 plus 6 plus 4 is equal to 14.
14.
And again we do is 1 into 2 plus 4, 6. So 6 becomes my, finally becomes my remainder. Somebody may check fully whatever this procedure is, I'm doing it correctly. Yes, 6 is correct. So you got it. Actually, in case of 9, we are habituated in doing so, isn't it? All of us probably do sometimes of the other in our life, that given a big number, whether it is divisible by 9 or what is the remainder in 9, we keep on adding that very big number. We first add them, again something comes, again we add that, and finally we collapse it into one single digit number. With 8 also we can do, provided instead of adding all these numbers, we because it is, we consider in case of 9 it was x is equal to 1, x is equal to 1 here. In case of 9, x was equal to 1. So we added all the numbers because one has one power is 1. But instead of that, in case of 8, you have to do with 2. In case of 7, you have to do it 3, and so on. In case of 12, you have to do it minus 2. In case of 11, you have to do it minus 1. Likewise. So understand some of this remainder theorem, what it gives. And now let us do.
Sir, if it is more than 10, if it is 11, we have to 10 plus 1, we have to add like that.
Yes. So you have to do minus 1. X is equal to minus 1. So replace this power, all these things, instead of 2 here, it will minus 1 to the power 4, minus 1 to the power 3, minus 1 square, and so on. So 12, already for 12 we have seen.
Okay, yeah.
Already in case of 12 we did already x is equal to minus 2, and we did with this one minus 1 to the power minus 1, and so on. Okay.
Yes.
So I'm sorry, minus 2 to the power 2 minus 2, and so on. So similarly, here also you have to do all minus 2 to the power 4 minus 2 in case of 12.
Okay. Thank you.
What more you can know this thing? Now I was doing a one thing, but it I have to redo it. It's supposed to work, but it didn't work somehow. Let me try.
Excuse me, sir.
Please.
X is equal to, we can put any number, whether it is a plus or minus. Sometimes we are putting x is equal to minus 2, x is equal to 1, like that. How can we consider this x?
Oh, what do we put? I told actually, if it is suppose here, I tell you. Here actually, the 8 can be expressed as 1 and minus 2. That means 10 minus 2. So all the 10s actually will be replaced by x. So this becomes x minus 2, and x minus 2 is equal to 0 means x is equal to 2. In case of 12, what we did in case of 12, this is 12. So it is 1 into 10 plus 2. First we replace all this x actually, 10 with x. So this is x plus 2. So x is equal to minus 2. So you remember that for 12 we have to do 12 we have to do with minus 2. In case of 8 we did with plus 2. Likewise. Suppose 16 we can do it 6. I mean minus 6. Now certain things, let me see whether I didn't try myself. Should have worked actually, but I don't know why it's not working. Suppose we have a number 156. Okay. This is my Q. So actually this actually gives rise to what? Now x square is 1x square because 1 is there. X square plus, please tell, anybody tell?
X.
5x plus 6.
X plus 6.
5x plus
5x plus 6.
Those of you who are expert in this quadratic equation, you can tell me the roots of this. This actually is
Plus 2.
X plus 3. X plus 2. X plus 3 into x plus 2.
exactly. Thank you. X plus 2, write in sequence, smaller together. So x plus 2 into x plus 3. Right here. Now, suppose giving a big number, say 2, 7, 4, 5, 6. I have to tell whether what is the remainder when 2, 7, 4, 5, 6 is divided by 156. So again, I take any one of them I can take. Either I can take x is equal to minus 2, or I can take x is equal to minus 3. But according to remainder theorem, I'm going actually. Whether I have understood correctly or not, let us have to see. So theoretically speaking, if 27456 is divisible by 156, so it should have the same kind of root. So here the roots are minus 2 and minus 3. So this minus 2 and minus 2 should also work there. I can replace it. So here power of somebody may tell, please. So 2 into, let's say minus 2, it is smaller number. To the power how much?
4.
4.
Plus 7 into
2 cube.
2 minus 2.
Minus 2. Minus 2.
Plus 4 into
Minus 2 square.
minus 2 square. Plus 5 into minus. So it is happening. It is happening after factorization. Earlier we did with only one factor. X is equal to 12, 8, small numbers. Now it is a 3-digit number, so obviously it may have a root like this. Now what is the division?
32.
32 minus 30. Oh, sorry, plus 30.
Plus,
Plus 30. I'm sorry. 30.
here it is minus.
Here it is minus 56.
Minus 56. 16 plus 16.
Plus 16.
Minus 10.
Minus 10. Plus 6. So minus 56, 32. So minus 14.
Minus 12.
This is minus 14 plus 16 minus 6 is 16 minus 6 is 6 plus 6. Oh, sorry.
Minus
24.
24. Minus 24.
So it is, oh, you told already, minus 12 you told, not directly you told.
Yeah, yeah, directly I told. Minus 12.
So minus 12. So minus 12. So it is remainder is minus 12 for 156. So actually it is, it cannot be minus 12. So 156 minus 12 is equal to how much?
144.
Now let me check. Can anybody check? It's very easy. But if we want to use calculator, no problem. 2, 7, 2, 7, 4, 5, 6, 4, 5, 6 divided by 156, 156, 176. So you multiply this 176 and replace this by minus. Somehow with these two factors, it is not working. Maybe that somewhere it is getting messed up. It says it is 0. Anyway, let's see what maybe somewhere it is some application may be wrong. I don't know. Let us do another one. Say now there is a 2-digit number like this, 23. Two-digit number, not 1. So it will come to 2x plus 3. Okay. So x is equal to minus 3 by 2. what to do in this case? I want to see whether a number, say 1, 2, 3, 4. I keep smaller numbers. What is the remainder when this is divided by 23? So what do you do? This is 0.
1 into minus 3 by 2 whole cube.
Minus 3 by 2 whole cube.
2 into minus 3 by 2 square.
2 into minus 3 by 2 whole square. Into minus 3 by 2. Yeah. So it becomes 9 by
Minus
20
9 by 8.
minus
9 by 8.
27 by 8.
27 by 8.
Nine by 4.
Minus 9 by 2.
Oh, sorry, it's minus 9. So, but how about tackle about this one? How to tackle about these fractions, denominator parts?
LCM?
We are also to see. Huh?
LCM you have to take?
Exactly. So this here I can know whether it is divisible or not. So suppose LCM exactly. So this I multiply everything by 8 in this case. Okay. So it
8,
becomes
yeah.
minus 27 and
36.
No, it is already 2 into 9 by 4. It is already 9 by 2. 36, right? 36.
36 again.
Again 36.
Minus 30.
Minus 36.
Plus 4. So ultimately becomes equal to
Minus 23. But it is, then we see whether actual answer. So somewhere these kind of things have to be taken care of, and how it is taken care of through remainder theorem. But I was applying just the remainder theorem as it is. So whether these kind of things in case of this is applicable or not, because remainder theorem is basically meant for polynomials of any order or something like that. In case of these things, I wanted to apply. So one this thing is right.
But we got the negative number, no? Minus 23 we got.
Minus 23 is actually, it means actually 0. There is no remainder, it says. But there is remainder. The answer is not coming properly. Actually, this, as I told, this one actually is applicable for remainder theory is very good for these algebraic equations like this. You have to divide these things by this. And big divisions. I can give examples. Somewhere I read with the case of number, I thought that the application can be there in this case because many persons are there who are will not be interested in algebra, but actually will be interested in calculations. So for them, it would have been all right. But this kind of applications, why it is not working, or other I'm not being applying properly, maybe compared to the cubic equation.
Please mute yourself. Please mute yourself in case you have any other issues.
Opposite this kind of fractions, it should not work actually. It is just
Okay, we go ahead.
Ah.
Instead of getting stuck here, we go ahead with the other course material because Tuesday is last day.
no. I have finished with this particular thing. Whatever is the
Right.
course. Was
Okay,
there
okay.
was there calculus also? Calculus?
It's up to you. You are a teacher. I mean, it's if it is essential, you can go ahead. Otherwise, the people who are not with a maths background may not be in a position to follow.
Yeah. There was a very interesting chapter of calculus, not calculus, let's see, the small equations. Because I don't know that what would be taken, so I have not put it into the slide. So let us see what best things we can discuss here. I was just going through the book, not that type of easy simple equation.
Otherwise, if people have questions, they can ask so that whatever has been taught till now, they'll be clear.
Whatever has been taught, so actually, there are equations like, should I put equations? So actually, from Vedic mathematics, these kind of equations can be solved. It says that say 1 by x plus 1 minus 1 by x plus 3. 1 by x plus 2 minus 1 by x plus 4. Any question? Any earlier about earlier things?
Yes. Now the forum is open for others to ask questions in case you have. Till whatever has been taught up to remainder theorem. In case you have questions, you can ask now. The forum is open.
Sir, the remainder theorem is not in our booklet, I think, present booklet.
Oh, it is not in this course?
Yeah, not that you have not given the PPT. You have given some notes, no, sir?
Oh, yeah,
There
yeah.
is no remainder theorem in that notes.
Yeah, I can slightly modify. I can these things I can insert because
Just I have verified, but it is not visible for me. Others can check up. Even yesterday, some problems also not found in.
those are not there. So now one thing can be done there.
But still, in case you have questions on that, you can ask.
Yeah.
Okay. He has designed the course to include Vargamola, that is square root and remainder theorem. So in case you have questions on that, you can ask now.
So later on, we can see with the video and follow. That is
Okay,
not the
and if you
problem.
don't have questions, no problem.
Thank you.
Somebody has questions, they can ask.
Okay, no problem, sir. Just what I
Yeah.
got.
Right.
Like idea. I asked.
Now there are examples like these. All of many of you know must be doing these things. Suppose there is a number like this. Okay. there is a polynomial like this. So it can be factorized as this one.
X
This
plus
thing-
1, X plus 2.
X plus 1, X plus. So given some big bigger polynomials, whether we can what
Two, sir.
consideration we can make using differentiation. Whether differentiation of this number gives me any clue for the factors. This is actually a challenge. There is a chapter called factorization and differentiation. So if I differentiate with respect to x, what happens here?
So it is X plus 2, I think.
Oh, sorry, x plus 2. I'm sorry. So if we differentiate, what happens? Anybody knows differentiation? You must be knowing, isn't it? Differentiation of this x square plus 3x plus 2 is 2x plus 3. So this becomes, see, again, the differentiation of this is 2x plus 3. Whereas if we just add that x plus 1 plus x plus 2. What is happening? Is equal to
2x plus 3.
2x plus 3. So there is a relation between differentiation and factorization. Is it not interesting?
Right.
Just make the summation of those factors and you are getting the differentiation. The value of the adding these factors and you are getting the differentiation of this number. So we can also see for say x square plus 5x plus 6. We know that it is x plus 2 into x plus 3. My handwriting is not coming okay. 3x, okay? I can erase, of course, erase. Achha. Then differentiation of this, anybody please tell?
2x plus 5.
2x plus 5. And here also see if we add these things, these 2x and
Plus 5.
5. So there has been a relation between differentiation and factorization. We go to more terms like, let us see now, the x cube plus 6x square. So how differentiation can help us factorization? That was the challenge. And so first you have to establish the relation between, understand the relation between differentiation and factorization, and then only you can do. So this factorization, if you do it, it's a little bigger. So I did it. I wrote from this book. How many people have this book? This book is went through also. How many people went through this book? that is given in the reference that Bharati Krishna Tirthaji's. This I will translate into slide. It will take some time, but since I didn't know that how many people, whether I will reach to this level or not. So this actually, suppose I didn't know this. Suppose this I know this factorization is there, but I suppose I didn't know that this factorization is possible like this. So differentiation of this is, please tell me, somebody, come on.
3x plus 12x.
Square.
3x square.
Sorry, 3x square plus 12x.
12x
Plus 11.
plus
11.
Plus 11.
now what is happening? Here you have to do summation of AB. Summation of AB. That means
3x. AB.
summation AB means, suppose summation AB means 2 at a time. So we do x plus 1 into x plus 2, 2 factors at a time, plus x plus 2, please tell me, into x plus 3,
X plus 1 into x plus 3.
x plus 3 into x plus 1, which is what? X square plus
3x.
2x, 3x.
3x.
3x
2.
plus 2. X square. Next one,
5x.
5x
6.
plus 6. X square plus 4x
4x.
plus 3.
3.
If we add, we get
3x square.
3x square
12x. 12x.
12x
11.
plus 11. That means my differentiation and again this factorization has relation. So this is the basis of the telling that it is differentiation and factorization. Suppose we get to more power, will also there will be some considerations there. So let me go to higher power. Now, but if it is a higher, then of course it is. So I go to x to the power. What time is there? Little time is there. Is it? Are you feeling interested by this?
Yeah, it is good.
Sir, one
I
doubt.
feel by, huh?
One doubt I have.
Please.
In the previous example, x square plus 3x plus 2. After differentiation, we got 2x plus 3, no? And again, we have taken the roots for x square plus 3x plus 2. We got x plus 1.
This example, this one.
X square plus 3x plus 2, you showed us as 2x plus 3 is a differentiation. Yeah, 2x plus 3. So we have taken the factors for x square plus 3x plus 2. So which is x plus 1 and x plus 2 factors. So you
We
have
add up. If we add,
equated with the differentiation with factorization. So directly we have added x plus 1 and x plus 2. So we got 2x plus 3.
it is actually summation A. Here only one term, only summation A.
If it is only one term, we have to add directly.
Yeah.
In the second one, we have 3. That is why you have multiplied and added all the 3.
Right.
Okay.
It is
Thank
2
you.
at a time.
2 at a time. Okay, sir. Thank you.
It's cubic equation. So 2 at a time.
Okay, sir. That is what my doubt.
Now we'll see even further. We will get like this. X to the power 4 plus 10 x cube plus 3 35 x square 35 x square plus 50x plus 24. So this is actually factorized as x plus 1 into x plus 2 x plus 3 and x plus 4. And
So
if
it is
we
10x cube, sir? Is it 10x cube?
Yes. It is 10x
Okay.
cube.
10x cube, 10 cube, not 10. Now, when you differentiate it, differentiate
4x cube?
4x cube
30x square?
at x square
70x?
70x
50?
We'll find that it actually a summation of, it will be very big, so I didn't do it. So it is summation of ABC. If you do summation of ABC, like x plus 2 plus x plus 2 into x plus 2, x plus 1 plus x plus 2 into x plus 3, plus x plus 2 plus x plus 3 into x plus 4, plus x plus 3 into x plus 4 plus x plus 1, plus x plus 4 plus x plus 4 into x plus 1 into x plus 2. Like 3 at a time, you do summation, you will get this. It will be very big. I'll come to that one, another one, D2. It was 4x cube plus 30x square is equal to, what is the again differentiation of that?
12x square?
12x square
60x?
60x. This is 2.
70?
60x plus 70. And here it is 2 into summation of AB. Means that you do x plus 1 into x plus 2 and again plus x plus 2 into x plus 3 plus x plus 3 into x plus 4 plus x plus 4 into x plus 1, 2 at a time, and whole thing multiplied by 2. It will be coming to same thing. Again, it will be bigger, so I didn't do D1, D3 is how much?
24x
24x
60.
plus 60. Here it is 3 times. It is 3 times summation of A.
A.
Let us see. If we add this is equal to 3 times. If we add all these things, x plus 1 plus x plus 2 something is wrong.
Yeah, it's something is wrong. It is coming to 12x only.
So actually 6 times. No?
Oh, 6 times. Factorial. Oh, sorry, factorial. Factorial. I'm sorry.
Factorial 6.
Factorial. It will always factorial. So actually it is factorial 2. Factorial 3 means 6. All things are factorial. 2 you didn't because 2 factorial is 2. So this is actually factorial 3. And that's what I read for before some time. Here this factorial symbol is there because I didn't practice it much. So it is 6 times summation of A. X plus 3 plus x plus 4, which is actually 4x plus
Now it is
4x plus 10, and 6 times of that is this one. So 6 times of this 6 into this is equal to this 24. In earlier example also, if we had we went this one, next this was D1. First order differentiation. Now suppose I get to second order differentiation equal to 6x plus 12. And if we add these 3 numbers, this becomes, and 2 into
factorial 2.
Factorial 2, that means 2 into the A, that means is equal to 2 into x plus 1 plus x plus 2 plus x plus 3 is equal to 3x plus 6. Is equal to again 6x plus 12. So, should we do more examples at that time?
Yeah, there is one question from Mr. Anand Kane. Let's take that question. Yeah, Mr. Anand Kane, you can go answer.
Yeah, thank you. Sir, I have more of a generic question. I got the book and I went through it, and several places it mentions that there were actually 16 volumes and they were all lost, and only one volume finally was rewritten by Guruji, Swamiji, and today we only have that volume. So there must be a lot of other knowledge, but now my question is that all of these sutras give us nice little tricks to do the various mathematical functions in an easy way. Most of it is mental mathematics. Many places you have to mentally understand what the relations are, and then you get that, right? So it is a matter of practice. So my question is that we still don't see this kind of the methods that are mentioned here in our regular scholastic mathematics courses. Especially what I feel is that this kind of tricks will be probably will be very much useful for students who are applying or who are appearing for competitive exams, like JEE and Maths Olympiad and you know, those kind of competitions. So is there an effort, or do the mathematicians today recognize these tricks, and do you see that?
So, first of all, I'll answer
to bring this.
First of all, you told that you are using so many times you use the word trick, and here is I have some objection. These are also as rigorous mathematics as we normally do. Those either you call everything as trick, even our normal multiplication as a trick, or you do not call these things as trick. So these are also alternative methods. As I told, you change the algebra and the method or the procedure changes. So that is the thing. So you have to understand the mathematics in all different points of views. So these are not tricks. These are rigorous mathematics and alternative way of looking things. And what our Swamiji here told in the preface, somewhere it shows, he has written that these methods actually all have relation with deep meditation also. Normally, if we have deep meditation and we learn all these different procedures, probably you will arrive that there are more shortcuts. Even you can discover more such things. So Swamiji's idea is that it has to be connected with deep meditation, and somebody in deep meditation, you can bring mathematics there in deep meditation, then everything will be transparent. Like Shakuntala Devi was practiced, I think the mystery of Shakuntala Devi was something like that. She used to go to a deep meditation with respect to mathematics, and she 23rd root of a 201 length digit number, she can do in she could do in 15 seconds. In that time, computer could not do. So there is a relation between the mental capability and this Vedic mathematics. So there, as you write, as you told correctly, that there are 10, you told 10 volumes. Maybe that is the case. And that Dr. Shesha Prabhu told in his lecture that probably Newton, Leibniz, all they got the idea of calculus from. There are volumes of the ship full of volumes of Bharatiya Shastra, Sanskrit literature was taken to European countries that time. And I don't know, nobody can know that what actually went through that one, and whether those people are influenced by this thing. They had also brain power. They also had very much good hold of mathematics, and they did a lot of things. But whether they were triggered by this our Sanskrit literatures or not, there is still, it will be always a mystery on this one. So let me do another example. This is it interesting? Should we go for one more example? At least there will be 4 terms, 5 terms. Okay, should I proceed?
No, you give homework, because now we are approaching 8 o'clock.
Oh yeah. Homework. Homework from what we can do.
Give you homework which is useful in our exam also.
Then you can do remainder theorem. Even we could not decipher properly that what was that this one. A small thing it worked actually. suppose using remainder theorem, one can use say whether this 27846 is divisible by 14 further. You can do what is the remainder if it is if it is divided by 14 or say 16, something like that. Okay. The same number, you do 27846. What is the remainder if it is divided by 15? Okay, one more. Vargamula. Vargamul, we do it, let me see an example. This was not stored so far. I'm not. Maybe I'll next time I'll do. This itself you can do, or you can you write 4. Please write 4 5 3 1
4 5 3 1.
Yeah. 4 5 3 1 4 5 3 1 and 9 8 2 4 9 8 2 4 square root Vargamula or this itself you try yourself. 69906320 69906321. Another one, another you note down please. 4 1 4 1 2 5 4 1 2 5 4 9 2 9 4 1 2 5 4 9 2 9, or a smaller one also you can do. Smaller one. Smaller one. 2 1 6 2 2 5. So Vargamula I gave 4 4 5 3 1 9 8 2 4 and 4 1 2 5 4 9 2 9 6 999 0 6 3 2 1 and smaller one 2 1 6 2 2 5. Note down, note it down.
Noted.
And state division also you do some. You do state division also. Two, 1, 0.068 divided by 46. Three 328 divided by 76.
I think that's enough. You have covered all the.
Yeah, yeah.
Yeah.
And some of these you can do yourself, like let us take a number. Four 932. 407,932. Whether it is divisible by 857 or not. 407,932 divisible by 857 or not. It will be a little bigger. Let me see whether smaller is there. This is divisible by 409 or not. 409. Looking very big, but very it will not be difficult.
Okay.
This small thing you can do. This one you do. 368869 divided by 23. Somebody please do 14 divided by 4, 14 by 41. Somebody please do 16 by 41. This method, negative method. I think it is okay. Thank you. Namaskar.
Thank you, Gautamji. Thank you so much. You have done a lot of spade work, I must say, and also hard work to educate us on Vedic mathematics, which is, slightly different and difficult. And we need to concentrate more. We have to do meditation, I think. As you said, we will do meditation and do this. It will be more useful. It will be more easy if we get into meditation or before or after meditation. After meditation.
Yes.
Thank you, Ji.
These are some, and that is how the our Bharati Krishna Ji wrote this book. The big book he is written by deeply meditating on these theorems.
Actually, firstly, we have to learn meditation. That's, of course, we are trying to do. Thank you so much. And on behalf of all the students, we are again thanking you. Now, Surya Prakash Garu.
Yes, sir.
Yeah.
Sir, am I audible, sir?
Yeah, sure. Please.
स्वस्ति प्रजाभ्यः परिपालयन्ताम् न्यायेन मार्गेण महीं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यम् लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अदना सदना सन्तु जीवन्तु शरदां शतं सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतङ्गमय ॐ शान्ति शान्ति शान्तिः पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः ధన్యవాదాలు సార్
ధన్యవాదములండి Surya Prakash Garu.
ధన్యవాదాలు సార్
Now let us all stand up and then recite national anthem along with CC Babu Garu. All of you mute your mics, please.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद
Jai Hind.
जय हिंद
ధన్యవాదములండి.